Welcome to Astro 101. My name is Sharon Morsing, and I will be your professor. With me is Jeanette Gladstone, Ross Lockwood, and Curtis Brown, who will be your guides throughout our voyage to a black hole. I did my PhD research on the insides of black holes when I worked on my PhD in theoretical physics. Over the years, I have also studied gravitational radiation and X-ray emission from black holes and neutron stars, which are dense, compact objects. I am fascinated by the force of gravity. How does gravity's strength depend on an object's mass and size? How does gravity cause light to travel on curved paths? Can we use the effects of gravity to observe black holes through gravitational lensing? And what exactly are the gravitational waves that scientists are so excited about?
Hi there, I'm Curtis. Some things you ought to know about me: when I'm not on my side hustle slinging plywood, I'm learning about black holes and studying engineering. I've been keen on learning about astrophysics since the very first time I watched my favorite science guy, Neil deGrasse Tyson. In my spare time, I make pipe cleaner mustaches and sit above the streets of Toronto in my palace of textbooks. My interest in black holes started in my undergraduate courses in astrophysics. We learned that black holes are the endpoint of stellar evolution for high-mass stars. What I'm curious to learn is how the mass of a star can create a gravitationally collapsed object, a black hole. I know it has something to do with the four-dimensional structure of space-time. But the thing that I'm really interested in is learning why massive black holes are much safer for astronauts and spaceships to visit than very small black holes. I can't wait to get started. I'll see you in the stellar nursery.
Hi, I'm Ross. I earned a PhD in condensed matter physics relating to quantum mechanics. As a result, I'm interested in the theories about microscopic black holes and the effects caused by quantum mechanics like Hawking radiation. I'm excited about learning what happens inside of a black hole, what would happen to an astronaut and their equipment if they crossed the event horizon, and what you would see if you looked towards a black hole's singularity. What would happen to an astronaut and the information they were collecting if they crossed into a black hole? And what about the possibility of them escaping from the black hole? But I'm most excited to be one of your teachers throughout the course. I'll see you in a little bit when we begin talking about Newtonian gravity.
Hi there, my name is Jeanette Gladstone, and I'm looking forward to helping you learn more about black holes while sharing some of my sci-fi favorites. I also have a PhD, but mine is in black holes, or rather, in observing them. Yes, I spent 3 years of my life in the UK testing theories and ideas that had been put forward to explain a strangely bright class of black hole. I know that sounds a bit of an oxymoron, but it's true. At the end of those 3 years, I got to call myself Dr. Jeanette, and then moved across the pond to continue researching black holes here at the University of Alberta. My background means that my favourite sections lie towards the end of the course, so I'm hoping you'll stick around to modules 8 and 9 to find out how it's actually possible to look at and study black holes. I hope to help you find the answers to questions such as: how do astronomers look at a black hole? How do they study them? And what do they look like? And more. Thank you for coming on this journey with us through space and time, and I look forward to chatting with you again soon.
In this course, we will be exploring these questions using animations, demonstrations, interactive learning objects, food analogies, calculations, readings, discussions, and other activities. In order to learn about black holes, we should first take a look at how black holes are portrayed in popular culture.